Here are the answers for the day 1 bell work. We're asked to simplify these division expressions. In question A, we have a monomial being divided by another monomial. Divide the coefficients. 15 divided by 3, that makes 5. Now divide the variables by applying the rule about how you divide variables that have powers. You have x to the third in the top, in the bottom is x to the first power, and the rule to divide powers is to subtract the exponents. So we get x to the second power. Another way to think of it is that the x that's in the bottom cancels one of the x's in the top, leaving 2 of them left over. Question B, we have a trinomial in the top, and it's being divided by a binomial. Let's factor both expressions to see if we create common factors in the numerator and the denominator. And if so, we can reduce the common factors. After all, that's what we did in question A, we reduced. So in the trinomial, it looks like all terms divide by x. That leaves x squared plus 5x plus 6. In the denominator, we have a difference of squares. So that makes x plus 2 times x minus 2. Now right now we don't have any like factors in the top and in the bottom, but I noticed that this trinomial factors farther. So when you're doing division, it's important to completely factor the numerator and the denominator. The trinomial will factor into 2 sets of parentheses. We have x times x, and then to make the positive 6, but for the middle to be 5, we want to go with a 3 and a 2. In the denominator, let's copy down our 2 factors. Instead of having separate terms with plus signs and minus signs in between, we now have factors, things that are being multiplied together. It's when you have factors that you can reduce. So the x plus 2 divided by the x plus 2 just leaves a 1. Nothing else reduces because the factor x does not match x minus 2, and the factor x plus 3 does not match x minus 2. So now we're ready to write our final answer. We have x times x plus 3 in the top, and in the bottom we're left with the factor x minus 2. You can put that in parentheses if you want, but because there's no other factor left in the bottom, it's typical to just write it like this. Now question C. It looks like we have a subtraction problem. 6 minus, and then a fraction. Well, think about what you know about subtracting fractions. We need to have a common denominator. Think of the whole number 6 as being 6 over 1. And then minus the 5 over x plus 3. If we want to have common denominators on these fractions, then we need this first fraction to also have a denominator of x plus 3. Let's multiply the numerator by x plus 3 and the denominator by x plus 3. Remember, as long as you multiply a fraction, top and bottom, by the same thing, you haven't changed the overall value of the fraction, just what it looks like. So this time we have 6x plus 18 all over x plus 3 minus, and then 5 over x plus 3. Do you see where the 6x plus 18 comes from? 6 times x is 6x, 6 times 3 is the 18. Now that we have common denominators, we can perform the subtraction. 6x subtract no other x terms, so that leaves 6x, and then 18 subtract 5. That makes positive 13, all over our common denominator. Here is the final answer.